One of the greatest obstacles to crafting health and wellness is identifying and controlling inflammation. It's at the core of all complex and chronic diseases, and it's the driving mechanism that underlies the most common symptoms that people like you struggle to overcome. Join us as we explore cutting-edge science and research to give you the information and tools you need to create the quality of life you want and deserve. And now, here is the host of Inflammation Nation, Dr. Stephen Noseworthy.
Hey everybody, welcome back to the podcast. We're talking about the functional hierarchy. This is the second part of what will be a multi-episode series. There is a lot to talk about to clarify what the most important aspects of human function are, and that gives us a place to start when we want to find out how to improve our health and our wellness. Excuse me, last episode I talked about this idea of the functional hierarchy, and again how it helps us sort out which problems to fix first if we find them, because you have to look for them to be able to fix them. And remember that skipping steps ends eventually, it actually creates a problem down the road, because you can't completely resolve a problem that is predicated on a different foundation, or in other words, a problem that has an underlying problem itself. And we talked about the first deal breaker. That's the term that we use for problems that, if left alone, will prevent progress. And the first deal breaker has to do with blood flow. And we would include things like blood pressure, and ultimately it's about the perfusion of tissues. It's the ability to deliver nutrients and things like oxygen, glucose, and fatty acids to your cells, so that they can use that oxygen and those fuel sources to make energy to sustain function and to sustain repair mechanisms. So it's critical that you look. Right? You have to look to find something to be able to fix. And metabolic issues become obstacles when you either don't look for them, or you do, but you don't know that you should prioritize them. And in fact, I can't tell you how many people I've helped over the years, mostly women in this context, simply by telling them that it's not acceptable to have low iron all the time, or to be slightly anemic all the time. And once we fix those things, which is relatively simple in most cases, it's amazing how many other things just seem to spontaneously improve. And maybe you're asking, well, why? Because you need enough iron to make enough hemoglobin to carry enough oxygen in your red blood cells to deliver it to your cells to make energy, so that your cells have energy to sustain function. It's really quite simple. It's very logical. You'd also be quite amazed at how many people I've helped with simple tricks to help them increase blood flow by correcting things like low blood pressure. In fact, let me tell you about a guy that I treated about 10 years ago. Pardon me, it was not long after we moved to Tampa. This guy flew in from Colorado to see me there in Florida, and he had been referred by another doctor for evaluation. He had been in a major accident several years ago where he was mountain biking and came down off a mountain trail along the side of a highway, and kind of overshot the shoulder, and he got clipped by a delivery van, and it threw him like 30 feet. And this guy was actually in a coma for 2 weeks as a result of this. And it had been several years by the time I saw him, but ever since he came out of the coma, he just wasn't the same. His brain just simply didn't work. He was fatigued all the time, common things like brain fog, confusion, his memory was shot, and more. He lost his job, his marriage fell apart. I mean, truly, it was a real tragedy in pretty much every sense of the word. Now, just in retrospect, his labs showed a low blood sugar, a reactive hypoglycemia pattern. He also had this low blood pressure. Again, we define that as anything consistently under 110/70. And so we knew, at least in part of his problem, was that he wasn't perfusing his brain. We couldn't get blood flow, or he couldn't get blood flow to his brain. And one of the things that we test as it relates to these functions, one of the things that we do in what we call a functional neurology exam measures the temperature differences in the left and the right hand to see if his brain is controlling blood flow to his extremities equally and symmetrically. And in his case, the difference was quite extreme. It was off by something like 13 degrees between the left and right hand. And we don't like to see anything more than about a 40-degree difference. And so we knew excuse me, that not only did he have bad blood flow to the brain had difficulty controlling blood flow to his peripheral tissues. And again, we can use simple measuring techniques like the temperature of the hands to really get insight into that. Now, the only thing that we did with him in the first few weeks was to teach him how to eat to keep his blood sugar up and stable. And I did prescribe some nutritional supplements that helped his adrenals and increased his blood volume. I'm not going to tell you what they are because chances are they might not help you. I mean, that was his prescription, not yours. But ultimately, that had the effect of increasing his blood pressure, which improved blood flow and tissue perfusion. And now that he was eating correctly, he was not only delivering more oxygen to his brain cells, but for the first time in years, his brain had a consistent fuel or energy supply. And after only 3 weeks of these very simple strategies, he said his brain was about 50 to 60% improved, which is huge. His blood pressure was consistently right at that 110/70 threshold. His blood sugar was stable, and the temperature difference between his right and his left hand had gone from a whopping 13 degrees down to about 6. Again, it wasn't perfect, but it was significantly better. Now, if I had not known about this functional hierarchy when I was working with him, if I didn't know about the importance of blood pressure to create enough blood flow to bring critical components for energy production to his brain cells, particularly, I could have easily made him worse by starting him on some like neurological brain retraining exercises, which is very common in the functional neurology world. So listen, if you don't know your blood pressure, if you don't know your iron levels, if you don't know your B12 levels, if you don't know if you're anemic, or maybe you do, but nobody has helped you understand that you need to prioritize fixing those, then that's the place to start. It's step number 1 in the functional hierarchy. And all it takes is a simple set of lab tests to figure this out. It's not rocket science, but it's often overlooked because everyone wants to skip steps and do the fancy stuff. So I don't want you to make that mistake. There's plenty of doctors out there and other practitioners that are making that mistake. And so let's kind of back up, see the big picture, understand what's important, and let's start with step 1. All right, let's move on to item number 2 in our functional hierarchy. And it's somewhat intertwined with the first priority. I've mentioned it already, and that is having a consistent and stable fuel supply. I want you to remember that there are 2 energy-producing pathways that your cells use to make energy. The first is the anaerobic system, which is where we use glucose to create energy, and we do that without oxygen. The other is the aerobic pathway that does use oxygen, and it also can burn glucose for fuel, but it can also burn fats and even ketones. For anyone listening who has a background in biochemistry, yes, I know that there are more details, but we're just sketching out the big picture for people who don't have that background. So please no hate comments because you know that I'm skipping stuff. And that's okay. We don't need to get super complicated. The big story, the big picture is enough for us right now. Now, there's a lot going on here, and we can't cover it all, especially in great detail. So I want to hit the high points. First of all, you may have heard of something called metabolic flexibility. I've spoken about it before in different episodes. Chances are, if you're out there perusing YouTube, different podcasts, social media, you'll hear people talking about metabolic flexibility. And for the most part, what they tell you is right, but they might be making one very easy mistake to make, and that is to turn metabolic flexibility into nothing but the ability to burn fat as a fuel source. But that's really only part of it, because metabolic flexibility is really the ability to burn either fat or carbohydrates as fuel. Now, in truth, we're all burning some fat and some carbohydrates or glucose, which comes from carbohydrates. We're burning both in some proportion as our fuel source all the time. So for all intents and purposes, you're never, ever really just burning only fat. You're never, ever only burning glucose from carbohydrates at any given time. It's almost always a mixture. There are some very rare exceptions, of course. You can engage in different activities that might bias you in one direction or another. For example, the activity where you actually burn the most fat in terms of the percentage of where your energy is coming from is actually sleeping, right? Sleeping burns the highest percentage of fat as fuel as compared to carbohydrates than any other activity. It's somewhere around 70% of the energy that you burn during sleep, which is not much energy at all because you're sleeping, but about 70% of the energy that you burn during sleep comes from fat, which means that you're still creating about 30% of your energy in the form of glucose. And so it's important to understand that when we talk about things like energy production and metabolic flexibility, you're always burning some fat and some carbohydrates. It just depends on how you're biasing that relative ratio based on your activities. Here's another example. This is the opposite example. During high power exercises, like a very hard but very short uphill sprint, like say something within a minute or so, almost all of your energy comes from glucose. But there's still a small amount of fat that's being burned in there as well. But if you think about it, the standard American diet is carbohydrate based. And many people who have lost a relative amount of capacity to use fat efficiently as fuel, because they don't lose it completely, but they lose a relative proportion of efficiency. This is one reason why so many people have increased body fat. It's the decreased ability to use it as a fuel source because they're running their system almost entirely on carbohydrates, or at least they're biased heavily in that direction. And so any fat that comes in through the diet tends to get stored as body fat, particularly if they're eating too many calories, if their insulin levels are too high, and there's other hormonal signals that might be off that would promote that. So people who have a carbohydrate or a glucose-dependent metabolism, remember they've biased it away from fat efficiency into glucose dependence. These people who also have lost some degree of their ability to use fat as fuel often have a couple of common following complaints. Number one, they don't do well on low-carb diets, right? As they drop their carbohydrates down, they tend to not function well. Usually that comes out as general body fatigue. It could be brain fatigue. It could be irritability. Their brain doesn't work. They can't focus. They can't concentrate. And also, if these people who are carb dominant, let's just use that term, carbohydrate dominant, they'll crash and burn on a ketogenic diet or with intermittent fasting strategies. That's just kind of the way it is. Now, are there outliers and exceptional cases? Of course, but this is the rule, that people who are running a carbohydrate dominant metabolism because of their physiology and how they're running their diet don't do well with low carb, keto, and intermittent fasting. So I want to be clear that this idea of metabolic flexibility, which is part of our second stop in this functional hierarchy, is the ability to switch into and out of higher fat burning states as needed. But it's not just about burning fat as fuel. It's the ability to tap into both fat and glucose as required. That's where the term flexibility comes in. So let me back out a second and talk about two major blood sugar problems that people tend to have. They tend to have either chronic low blood sugar or chronic high blood sugar. And I'll spend a little time in this episode talking about this thing called reactive hypoglycemia, which is a low blood sugar issue. Again, I've done other episodes on this. You might want to go back in the list of episodes and look for that. And then we'll save the discussion about the spectrum of high blood sugar for probably in the next episode. But we call chronic low blood sugar functional or reactive hypoglycemia. And we call chronic high blood sugar either insulin resistance, metabolic syndrome, or type 2 diabetes, depending on how bad it is, because those are all just different versions of the same underlying problem. There are other major types of blood sugar problems. There's type 1 diabetes, type 1.5 diabetes, there's type 3 diabetes, which we call Alzheimer's, and there's what we call mixed dysglycemia, where you have elements of both. We're not going to cover them here. We're just going to talk about high blood sugar and low blood sugar in general. So let's start with a quick review of reactive hypoglycemia, functional hypoglycemia, or low blood sugar. And let me remind you why this is important, because low blood sugar is a deal breaker. It's a fundamentally, it is fundamentally important in the hierarchy because, again, most people run glucose-based energy systems. They are carbohydrate dominant in their fuel supply. And then when blood sugar drops and they can't tap into fat as an alternative fuel source, it interrupts the supply of fuel. And as a result, energy production goes down, and function changes in some way. So ask yourself this: how often do you feel something's not right if you don't eat, or if you don't eat enough, and then you feel better pretty quickly after you eat something? Usually it's going to be carbohydrate-based, maybe sugar-based. The answer to that question will give you a sense of whether or not you have reactive hypoglycemia, and perhaps even how bad, because the more frequently this happens, the worse your problem is. Now, if this is a once a month thing, that's really not much of a problem. But if it's happening, say, several times a week, or worse, every single day, or sometimes multiple times a day, then this is a major issue that has to be dealt with before anything else. Why? Because you need fuel to run your cells and your systems, and anything that interferes with consistent energy production needs to be fixed as soon as possible, before other things. All right, let me give you some more detail. If you find yourself feeling tired, or nervous, or anxious, or you get irritated or hangry, or if you get a headache because you haven't eaten, and that all gets better or goes away once you do, you need to fix it. And you need to fix it now, because it is fundamentally more important than other things, because all those other things that you might want to go fix are predicated on this function. Now, how do we fix it? Well, of course, it depends on the cause. But the most common problems are bad eating habits, usually eating too few calories or eating too infrequently, sometimes combined with poor adrenal function. One or the other or both are going to get you there, and the discussion for adrenals will happen later as we continue to work through the functional hierarchy. So let's talk about eating strategies for people with low blood sugar, and I'm going to give you my rules for eating with functional low blood sugar, functional hypoglycemia. Number one, eat enough throughout the entire day. Now, this requires personalization, and how much you need to eat depends on a few things, like how big or tall you are, how much muscle you have, and how you use that muscle or not during your daily activities and during your exercise. So there's no one quick answer as to how much food you need to eat. There are tons of online calculators that will estimate your daily calorie needs for you. Just Google something like calorie calculator and you'll find one to use. They're all pretty much the same, so find one that you like and eat at or close to whatever number it gives you, assuming that you feed it correct information. So it's going to ask you your age, your gender, your activity levels, how much you weigh, and it will calculate things and basically give you a number. And it's an estimate. So don't obsess over trying to hit the number with perfection as you count your calories throughout the day. Just get close. Get within 100 calories or so, either high or low, because over the period of a week or two, it's going to average out. Some days you're going to be a little under, some days you'll be a little over, some days you'll be a little closer, sometimes you'll be a little further away. But anytime you have a functional hypoglycemia, rule number one is you have to eat enough food, period. No arguments. Rule number two is you have to eat frequently enough to keep your blood sugar from dropping. Now, let me say this, is that a lot of people who have this type of problem tend to wait until they lose function before they know that it's time to eat. That might be getting nauseous. It might be getting anxious. It might be getting a migraine. The problem is by the time you waited for that signal to tell you, hey, it's time to go eat, I'm getting a little hangry and irritable, you've already lost the battle. In an ideal world, you should be able to go all day without eating and still function just fine. This is, part of the premise of intermittent fasting, is that you can stop eating food for a period of time and still maintain functionality, because your body says, okay, you're not going to feed me. I'm going to tap into the fuel sources I have, and I'll just wait it out until you decide you're going to eat again. Right? But the mechanisms that allow someone to go all day without eating, or for hours, sometimes even days, the mechanisms that allow that to happen don't work in people with this problem. That's why they have the problem. So you have to eat on a schedule and not wait for the symptoms of low blood sugar to hit you before you decide to eat. And a great way to do this is to understand how long you can go without food before something feels off. And whatever time that is, eat 30 minutes before. So if you can only go 2 hours without feeling tired or cranky or whatever, you need to eat every hour and a half for now to prevent it from happening, right? And that number might be different for you. It might be 3 hours. It might be every hour. The point is, stay ahead of it. because you'll never win this battle if you wait for the symptoms to start before you feed your system. Rule number 3, eat within 30 minutes of waking up, right? Since technically you've been fasting while you were sleeping, your body and your brain probably need some kind of injection of fuel as soon as you wake up or pretty soon thereafter. Now, again, let me remind you, you should be able to get up and choose to skip breakfast and not eat until lunch or closer to lunch and be perfectly fine. But if you're not, don't rationalize that away. It's a problem. One of the ways you can start to fix it is eat within 30 minutes of waking up or pretty soon thereafter, right? Now, many people with low blood sugar issues like this, they're not hungry, or maybe they're sometimes frankly nauseous when they wake up, so they tend to skip breakfast. And that's a big no-no, because at some point their blood sugar crashes and they have to scramble to find something very quickly. And by then, again, the damage is done and they're simply playing catch up and they never, ever get ahead of the problem. Well, and you might be saying, well, I'm not hungry in the morning. Like you said, I'm not hungry. Which leads me to my final rule for eating with low blood sugar. And that is to understand that your hunger and satiety signaling systems don't work and they will lie to you. Right? It's well known that hunger and satiety signals from the brain get dysregulated in these circumstances. Now, these are complex systems with a lot of moving parts, but let me boil it down to this. Some people are always hungry, even though they don't actually need food, but they keep eating because they're still hungry. And others are never hungry when, in fact, they need to eat something. And so they keep going off. They make their decisions to eat or not based on hunger signaling and satiety signaling that is lying to them. So your brain, which is where these signals to eat or not eat come from, it will lie to you until you start to feed it consistently and well. What you'll find is that if your hunger signaling and satiety signaling is off, tricking you into either eating too much too frequently or not enough, not frequently enough, as you continue to practice these rules that I've shared with you, make sure you're eating enough food, eat first thing in the morning, eat on a frequency that maintains blood sugar and functionality, these signals will start to become accurate. And at some point you can go, okay, I really am hungry. I really do need to eat something. Now, you can't use if you're hungry or not to tell you when to eat when these signals don't work. The most important thing for you to do is eat, number 1, enough calories during the day to meet your energy demands. Eat on a schedule, as I just said, to prevent your blood sugar from tanking, and to do that if you're hungry or not. In this case, you need to eat for function before you eat for anything else. All right, that's a wrap for this episode. That's the first part of our second priority in the functional hierarchy, talking about functional low blood sugar conditions and some things that you can do on your own to help try to sort that out. Next time, we're going to talk about the other major type of blood sugar issue, and that's the high blood sugar spectrum that starts with insulin resistance. If this is the first episode that you've dropped into, welcome. You can check me out at my website, drnoseworthy.com. You can find me on major social media channels. All the links are in the episode description. Please remember to comment, rate, like, and follow. It helps others like you find the information that they need to begin their own healing journey. Because after all, are we not all in this together? Well, of course we are. I'll see you guys in the next episode.